So, greetings for the day to all of you. I am Dr. Amarpreet Singh in front of you with the yet another lecture of the subject Artificial Intelligence. And the today's topic is Alpha Beta Pruning. So, the topic that we will cover today is Alpha Beta Pruning. It is very important topic from the examination point of view or any competition exam point of view. So what is alpha beta tuning? So let's start with this topic. So we have done in our previous lecture that the min max algorithm. So we have done min max algorithm. So what happened in a min max algorithm? So it is a game playing algorithm, and this algorithm is suitable for two players. Two-player game having two players, and max and min are the two players. So first player is max and second player is min. Both the players play the game with their alternate moves. First move is taken by max, then second move by min, or alternatively, if first move is taken by the min, then second move is taken by the max, and they play the game. One thing important in min-max algorithm was that everything is taken with perspective to max. So whole game is discussed taken into perspective of max. So max is the pivot point. What we desire here that max should win. So what is the strategy behind max and min? If there is the turn of max and it has options of many moves, and max has to select one move on its turn. So strategy is max will select that move which will fetch maximum point to max. So max will select the that move which will point maximum point to max. Maximum points to max. And alternatively, then there will be the move of min. Now min also have got on the basis of the max move. So min will also have the plausible moves. So min will select that move that will fetch minimum points to max. So min will not go for that move which will fetch maximum point to min. No. Min will also select that move that will fetch minimum points to max. So everything, the move of max and the move of min, both are in perspective of max. Means how many points max will get. So max will try to gain maximum point and min will try to fetch minimum point to the maximum. So this was the strategy in min-max algorithm. It required the plausible generator that generates the plausible moves. And then min and max on their turn, they select their moves. This was the min-max algorithm. So if we talk about the complexity of the min-max algorithm, that is on the order of complexity of min-max. The order is O B the power D, where B is the branching factor like this. How many branches it has, and D is the depth factor. So a particular branch, what is the depth of the? So this is the complexity of the min-max. So this is not considered good in terms of the complexity because it is very complex, and if the tree is very large. So here only the tree is one level 0, 1, 2. But if the depth of the tree is very high and the branches are also very large, it will take lot of time and it will be very complex to solve, because in min-max we have to traverse the whole tree, the whole game tree. So all the plausible moves which are present represented, all the legal moves is represented by the game tree. So in min-max, with this complexity, and this is the complexity, and if B and D is very high, then it becomes very complex, because we have to traverse the whole tree and it will take very large time, very more time. So we have, so this is the basically the disadvantage, or you can say limitation of the min-max. So now we have to look upon any technique which removes this limitation, and that technique is alpha beta pruning. So what does the term pruning means? Very important thing is we have to see what is the terminology of pruning. Pruning means cut. Pruning means cut. It means cut. So according to alpha beta pruning, it has some rule that I will discuss now. If that rule satisfies, then some of the branches gets pruned or gets cut, that need not to be exploded. So suppose according to alpha beta pruning, and this is the min max tree, game tree. According to min max, we will have to search the whole tree. But if we apply alpha beta pruning, then it may happen that this branch gets pruned or this branch gets pruned. So if how it gets pruned, I will tell you. If it gets pruned, then this tree under this branch has not to be explode. Similarly, this branch has not to be explode. So thus alpha beta pruning will save the time, and we need not traverse the whole geometry. The branches which are pruned, we will leave them and it will save our time. So this is the basic concept of the alpha beta pruning. So this is the main advantage of the alpha beta pruning over the min max. Over the min max. Clear? So one thing is complexity of min max is order of V the power D. O B D. Remember this thing also. I am telling it again and again. So how alpha beta pruning works upon, what are the terminology, some of the terminologies which are used in alpha beta pruning, that I will discuss. So let us solve this tree in front of you with the help of min-max algorithm. First of all, solve it with the help of min-max algorithm. Now suppose this is max player, this is min player, and this is also max player. These are the terminal nodes, and that is the utility value. I will cut this, it will make it clear. I will write alpha beta pruning here. It is not visible, that means a little bit lower. Alpha beta pruning is there. This is max. According to min max algorithm, what happens? We come to the terminal nodes. These are the terminal nodes with their utility values. So we suppose that actually there is the worst values of, we start with the worst values of max and the min. The worst values of max is denoted by alpha, and its value is minus infinity. And the worst value of min is denoted by beta and its value is infinity, because maximum wants to fetch the maximum points to himself. So, but the worst value is minus infinity, and beta or minimum wants to fetch the minimum value to max. So worst case for min is infinity, means it will fetch the maximum values. So it is the worst case for min. So therefore we have to see this thing. So we start with, here it is the max term. In the max term, the alpha value gets changes, and in the min term, beta values get changes. So here we have alpha, and maximum value of worst value of alpha is minus infinity. So 2 and 3. So now here it is the max term. So here alpha value is minus infinity, it will get 2. So 2 is maximum. So it will come 2 here. Then 2 and 3 will be compared. 3 is maximum. 3 will come here. Similarly, at this stage also, alpha is having minus infinity. 5 is greater than minus infinity. So 5 will come. Then 5 and 9 are compared. 9 is better than 5. So 9 will come here. So it is going through the min max algorithm. Here it is 0. Here it is minus infinity for alpha. So 0 is better. So here 0 will come. 7 is better than minus infinity. 7 will come. 7 and 4 are compared. But 7 is better. 4 is less. So here it will be 7 only. 2 is better than minus infinity. 2 will come. 2 and 1 will be compared. 2 is better. It remains there. 5 will be compared with minus infinity. 5 is better. Then 5 is compared by 6. 6 is better. So 6 will come here. So this is the max value. Then coming to this level, now it is the min term. Min will have the, try to get the minimum point. So it will start with the worst value of beta, that is equal to infinity. Means at this moment, beta is giving infinity to the max. So above min, there is max. So whatever the turn here it will play, it will move upward. So beta will fetch at this moment infinity. That is the worst case. But we have to search through this level also. So now beta can have 3 or 9. First 3 will be compared. So it is applying, giving infinity. So if this value is transferred, if it comes to this path, it will give 3. So what is better for minimum? So 3 is better, because so it will fetch 3 now. So this value comes here, and 3 and 9 will be compared. So this coming to this branch. So here 3 is there, here is 9 is there. 3 and 9 will be compared. 3 is less, so it will remain 3 here. Coming here, here also beta in the initial applying infinity. Here it will be compared with 0. So 0 is better. 0 comes here. 7 and 0. So 0 is better for minimum. Less than 7. So it will remain 0. Coming to this side, here also beta is infinity. So here it will give 2. Yes, 2 is better. And 2 and 6. So 2 is already better than 6. Now this level is also completed. Coming to this. Here A have the option of 3, 0 and 2. So here max is there. Max will get the maximum point. So it will go 3 and 0. Here alpha is minus infinity. So at present it is having minus infinity. So it will give 3. So 3 is better than minus infinity. So 3 will come here. Then comparison with this, 3 and 0, 3 is better. Comparison with this, 3 is better than 2. So overall final value of the max will be 3. And this branch is better. But we have to traverse the whole nodes. All nodes are traversed. So now we will come into the alpha beta pruning, and we will see that some nodes or the branches will be pruned on some condition. So let us see the alpha beta pruning and make this tree equivalent to the previous tree, what was the in original. So I will rub all the things. Let me clear it. So now I start with the alpha beta pruning. So one thing is clear that we start with the worst values. For max, worst value is the value, worst value is denoted by alpha and worst value is minus infinity. For min, the worst value is denoted by beta and the worst value for min is infinity. Clear? So as alpha beta pruning or min max, it is the advanced version of the min max. So it is depth first search. It is depth first search. So initially all the nodes will have this value, alpha and beta. So here you give this value, alpha is equal to minus infinity, beta is equal to infinity. You can write for all the nodes, alpha is minus infinity, beta is infinity. Here also you can write alpha is equal to minus infinity and beta is infinity. Same here you can write all the things. So first we have to move this way. So let us move this way, this branch. So under this branch, let us give alpha here equal to minus infinity and beta is equal to infinity. So we start with the worst values. So according to depth first search, we will come here. We come here. So at max, the value of alpha gets changed. At max, the value of alpha gets changed, and at min, the value of beta gets changed. Remember this thing. At max, the value of alpha gets changed, and at min, the value of beta gets changed. And what is the condition for pruning? Now remember the very important key thing. The condition for pruning. So alpha is greater than beta, greater than equal to beta. When alpha is greater than equal to beta, that branch gets pruned. That branch gets pruned. So we will see where which branch comes under this condition so that we can prune those branches. So you now be very careful, and I'm going to solve the whole tree according to alpha and beta. So this is alpha is equal to minus infinity. Again, I'm saying alpha is equal to minus, we start with the worst case, and beta is infinity. So we come according to depth first search, we come down. At max, we will compare the value of alpha. We will ignore beta. So at this moment, just see alpha is greater than beta. No, alpha is minus infinity and beta is infinity. So no pruning takes place. Now we have to compare alpha with 2. So alpha is having minus infinity. It has got, if it follows this path, it will get 2. So see, compare alpha at present having minus infinity. If it follows this path, it will get 2. So 2 is better than minus infinity because maximum wants maximum point. So 2 is better than minus infinity. So alpha gets 2. Alpha gets 2. So see, alpha is 2 and beta is infinity. This condition holds? No, this condition does not hold. Then compare, come to this branch. Alpha is 2. From here it will get 3 if it follows this branch. So this branch is better because it will get more value. Now it is having 2, it will get 3. So yes, so 3 will be shifted to this node. This node provides 3 here. So 3 shifted to first of all 3 shifted to this node. We will write 3 here, and it gives, here it is 2. So 3 will be given. This node will provide 3 to alpha. So yes, 3 is better. So you give 3. Okay. So this is 3. So this nodes can get maximum or greater than 3. So we have got 3. Clear? Any doubt? Now what happens? This node value is taken upward, but alpha and beta values are taken downward. Node value is taken upward, but alpha and beta values are taken downward also. So now we have solved this. Now we will move to, according to depth first search, we have to come here. So this node is providing 3 here. This node is providing 3. So what we will do? At moment min turn is there, so value of beta will change. At present, beta is giving infinity to max. Beta is giving infinity to max. But if beta follows this branch, it will come to this node, and this node value now it becomes 3. It will provide 3. So what is less? Infinity is less or 3 is less? So 3 is less. So this node value will come to beta. So node value can go upward, but the alpha and beta value come downward. So here it gets 3. Here it gets 3. Now come to this part. This part. Now you can transfer these values down also. Alpha come here and beta come there. Here beta can be 3 now. Beta can be 3 here, and alpha is minus infinity. So you can shift the value of alpha and beta downwards, but not upwards. But node values are carried upwards. So here it is a turn of max. We will change the value of alpha. Whatever the value you have, you can bring the value of alpha and beta downwards. So alpha becomes minus infinity, beta here it becomes 3, so it becomes 3 here. So here the value of alpha worst value is minus infinity. So it is the max turn. Value of alpha will change. So it is having minus infinity. If it comes to this branch, it will give 5. So 5 is better than minus infinity. It will take 5. This 5 comes to this node, means this node will provide 5. So 5 comes here. Okay. As and when 5 comes here, as and when 5 comes here, you see the condition alpha is greater than equal to beta. Alpha is greater than equal to beta. Clear? So this value comes true. So this node will be pruned. This branch will be pruned. We will prune it. Clear? We will not go for this. So you leave. So according to alpha beta pruning, this branch will be pruned. So what happens? You suppose that whatever that, if this would not have been the leaf node, suppose here it would have any node and further it has having any tree. So we need not traverse this branch forward. Whatever the depth factor this branch is having now, so we will prune it here. So this is the benefit of alpha beta pruning. You look this way also. If it is 3 here, otherwise, so from 3, if we carry 3 here, min turn, if min follows this branch, 3 comes to this. And if it goes for this branch, so either 5 will come or either 9 will come. In min max, we took 9 here. But whatever the case, from 5 and 9, 3 was the better. 3 was already better. So this 5, after 5 and 9, nothing can come to this side. So because this branch will always give value greater than 3. And we want here the value less than 3. So here the minimum value it can have less than or equal to 3. So this branch gives its this value, but from here it will give always the maximum value. So therefore we will Due to this, alpha becomes 5, beta becomes 3. So we prune this tree. So we will not go for this branching, whatever the tree is under this. So this branch will not be traversed anymore. So we will reduce the complexity and time will be saved. So this part has been solved. Now let's come to this part now. This part. So here, so it remains. So it was providing 5. So 5 will not go there. This node was providing 5. So 5 will not go there. So this node has 3. So the value set for this node is 3 now. So this value is carried upward now. The value of node. Now it is the max turn. We have to come to this node. Then according to depth first search, we have to go there. So it is the max turn. Alpha will be changed. Alpha's values is minus infinity. Alpha's values is minus infinity. So if it comes to this branch, so alpha will get 3. So 3 is greater than minus infinity. So 3 will be shifted here. So alpha gets 3 and beta gets already infinity. Now I said the value of node can be transferred upward. That has been transferred. But the alpha beta value goes downward. Alpha beta value goes downward. So let us bring this alpha value 3 here, beta value infinity here. Same also alpha value 3 here, beta value infinity here, alpha value 3 here, beta value infinity. Alpha value 3, beta value infinity. Now let's come. So from C, we move to this side. From C, we move to depth first, we come here. We come here. Here it is having, alpha is having 3 and beta is having, so it is the turn of max. Alpha will get the points. Alpha will get the points. So what happens? So 0 is there. Beta, we will not consider beta here because it is the max turn. Alpha will be there. Alpha is having 3. This node provides 0. So 0 is not better than 3. So 0 remains here only. 0 remains here only. It will not shift to alpha. So this has been solved. Let us take here. So alpha is 3 and this node value is 0. So this node value is providing 0. So node value is 0. You have to write the node value here. Node value is 0. Coming to this point. So if it comes to this, now beta. So node value is 0. Now it is min, beta will be changed. Here beta is having infinity. If it comes to this node, node value is 0, it has not gone to alpha. So node value 0 and beta value infinity. So beta wants to give minimum value. Beta wants to give minimum value. So 0 is minimum then infinity. So 0 will shift here. I am saying node value goes there, alpha and beta value comes down. So node value was 0. This was not given to alpha because this node is providing 0 here. Alpha is having 3. So 3 is maximum. So alpha does not take. This node is providing 0 here. Beta is having infinity. It is min turn. It will go for less. So infinity and 0. So 0 is less. It comes here. When it comes here, just see that this condition. Alpha becomes greater than beta. Alpha becomes greater than beta. So this whole tree will be pruned now. Whole branch will be pruned now. So just see here. So here whole branch is pruned and it is due to beta value became less than alpha value. So it is known as beta cut. It is known as beta cut. At this point, alpha value became greater than 5. Alpha became 5, which was greater than beta 3. So this cut is due to alpha value became greater than beta. So it was the alpha cut. But here alpha value is 3, beta was infinity, 0 came to infinity to beta. So beta value goes down from alpha. So it is beta cut because we change the value of beta. So that value becomes less than alpha. So it is the beta cut here. So this tree is pruned. So now let's come to this. Now you carry this one here. So alpha is 3, beta is infinity. Alpha is 3 and beta is infinity. So you come here downwards. So alpha is 3, beta is infinity. So it is max turn. Alpha value will change. This nodes provide 2. So alpha is having option of 3 or 2, but 3 is better. So it will not take. Okay. Then from here also, it will provide 1. So it will not take. So 2 remains here. The node value 2 remains here. And alpha value remains 3 here. Now we move to here. Then we will come downward. So here we are having alpha 3, beta infinity. So this nodes, if beta goes to this branch, beta is having infinity, this branch will provide 2. This branch will provide 2. So what is minimum? 2 is minimum. So beta will take this 2. So this 2 will go there. I said node value was 2. 2 comes here. Okay. So as here also alpha is 3, beta big 2. So this condition satisfy. So this branch will also be pruned now. And it is again the beta cut because value of beta changes from infinity to 2 and alpha was 3. So alpha becomes greater than beta. So this, so just see in min max, we have to solve the whole tree. We have to solve the whole tree. But here we have pruned this branch, we have pruned this branch, and we have pruned this branch. So it will reduce the time, complexity is removed, and the main condition is alpha is greater than beta. So to sum up, so just see from here only. So it is providing 2, alpha is 3. So this node value becomes here 2, and this is branches. Now it is the max turn here, come to upward now. So this branch is providing 3. Alpha is already having 3. So 3 will be there. This we have already shown. And here, from here, beta goes there. It will give 2. But it is the term of maximum. Maximum alpha value will change. Alpha is having 3. So it is not providing better value. So 3 is the result. So here also, the max gets the 3. So if we had solved earlier according to min max, again the final result was 3 there, and here also according to alpha beta pruning, the final result is 3. But the benefit is that, advantage is that we have pruned this tree, this branch, and this branch. It means so under this if these are not the terminal node, whatever the tree it might have under this, so we have saved our time. We will not solve this whole tree, this whole branch. Again also under this, if it is having any number of branches, so we need not to solve it. Also under this, if we are having any number of branches, we need not to solve this. So this is what is the alpha beta pruning. So you have to identify first of all the terminal nodes also. So here it is the terminal nodes, the nodes where the utility values are given. So whatever the shape it may have this shape also. So again it is the having the utility values. So from the utility values you come to know the it is the terminal node, and changes can be made here. You can be given the game tree with min here, max here, and min here. So you have to apply accordingly. If it is min, then beta value change. If it is max, alpha value change here. But actually in your case, it was given max, min, and max. So very important, I repeat again. So in alpha beta pruning, we prune the trees. The condition we start with for max, alpha value, and for min, beta value. Worst value, we start with worst value for alpha is minus infinity, and for beta is infinity. We start with the worst values. This you have to remember. Then the terminating condition is, pruning condition is alpha is greater than beta. Next point you have to remember, at max value of alpha gets changed, at min value of beta gets changed. Next thing you have to remember, that node value, here 2 will become the node value of E. This node value is supplied to alpha or beta, whatever the max or min case. So if it suits node value, then alpha value or beta value gets changed. If it does not suits, node value remains here. Then this comparison will also be made. So this will provide 3. So 3 comes here. So if node values and we come upward, then node values goes upward, means here beta can get this 3. So here you apply this, greater than equal to 3 means at this point the maximum value it can get is 3, and at this point the minimum value it can get 3. So it was fixed. So you saw that this branch was providing either value 5 or 9, but minimum it can get 3. So this branch is not providing any value less than 3. So this branch was pruned. So this branch was pruned. Here also this 0 became here. So this branch is getting 0. So it can get any value less than 0. But here all the values, either the 7 or 4, whatever comes here, it will be more than 0. So it is no need to solve this branch, because this branch will not provide any value less than 0, and this node is already having the 0. So this is the case. You can bring the alpha beta value downwards, but the value of node is always taken upward. So this is all about the alpha beta pruning, and it is the advantage of, it has got advantage of over min max algorithm. So min max algorithm is also done, and the alpha beta pruning is very important concept from the any point, examination point or any competition exam point. So again you can see this is the condition for pruning. This is the starting conditions. Node value gets upward, alpha beta value gets downward. And you start with the utility values which are given at the terminal node. So this is all from my side in terms of alpha beta pruning. So student, again I will revise what we have done and compare between the min max and the alpha beta pruning. First I start with the min max. Min max, two players game. First player is max, second player is min. Game is played with perspective of max. Every decision has to be taken with perspective of max. Max strategy is fetch maximum points to max. Min's strategy is fetch minimum points to max. To start with, we have the worst values for max and min. Now I will again come upward. Worst values for worst value for max is minus infinity. Worst value for min is infinity. And complexity of min max is of the order O b raised to the power d, where b is the branching factor and d is the depth. So this is all about the min max. The main disadvantage, if tree size is very high, it becomes complex and time consuming. So therefore, to overcome this problem of the min max, we move to the alpha beta pruning. So in alpha beta pruning, some of the branches gets pruned. So we need not to traverse the whole game tree. Some of the branches gets pruned. So what is the condition for pruning? Condition applied for pruning is alpha is greater than equal to beta. When at any node alpha becomes greater than beta, we say the pruning is there. So this is the condition which is applied for pruning. Whenever alpha becomes greater than or equal to beta, the branch under that node gets pruned. Next important thing in alpha beta pruning is when we have the tree. So finally we have to write when we solve the tree that how many alpha cuts and beta cuts were there. So if any tree is given to you, you solve that tree, you mark pruning here, but you have to tell this pruning is due to alpha cut or beta cut. So that we have to tell in the end after solving. So how many alpha and beta cuts? In our example that we did, we had one alpha cut and two beta cut. So if alpha value become greater than beta, it is alpha cut. If beta become value become less than alpha, it becomes beta cut. And the points that we have to remember while solving the game tree according to alpha beta pruning is node. We have to follow depth first procedure because min max is depth first search but depth limited. That depth limited is implemented through alpha beta pruning. Depth first procedure we have to follow. Then we have to remember, we start with every node starts with worst value of alpha, that is minus infinity, and beta, that is infinity. At max level, value of alpha gets changed or compared. At min level, value of beta gets changed or compared. So this is the point you have to remember. Node values move upward. Alpha and beta values can be taken downward, taken down the tree. Downward. So after the solving, you have to specify the node value at each node. As if it is the maximum level, then you specify the node value like this, greater than equal to node value. If it is min level, then less than equal to node value. This is very important. And in tree, you have to specify the pruned branches as cut. You have to specify the pruned branches as cut in a final tree. And in the last, you have to make the table, and there you have to write number of alpha cuts and number of beta cuts. You can also specify the nodes where the alpha cut became, what are the nodes where alpha cut came into the action, and what are the node where beta cuts came into action, and also provide the value of alpha and beta at that particular node. So this is the result table that you have to make. So this is all about the alpha beta pruning. So again, I have told you the main difference between min-max and the alpha beta pruning, and each and every step of solving the alpha beta pruning. Thank you.